For this problem, we're going to solve a logarithmic equation. We have log base 2 of x minus 4 plus log base 2 of x plus 4 is equal to 3. I'm going to solve this for x. We have these two logs on the same side here with the same base, so we can use our rules for logarithms to combine these together. In particular, we're going to use the product rule since we have the sum of two logs with the same base. So we can rewrite this as log base 2, the product of these two insides, x minus 4 times x plus 4, and that has to equal 3. I'm going to clean that inside up a little bit. See, x minus 4 times x plus 4, that's going to be a special form when we multiply that together. Look at the difference of two squares, x squared minus 16. That equals 3. We've got a logarithmic form here. We want to change that to an exponential form. So we're going to take the base 2, raise that to the third power, and that has to equal the inside, x squared minus 16. 2 cubed is 8. Well, 8 is equal to x squared minus 16. I'm going to add 16 to both sides, so we get 24 is equal to x squared. To solve for x, we take the square root of both sides. So we get x is equal to plus or minus the square root of 24. And we can simplify this radical as plus or minus 2 root 6. Again, as with a logarithmic equation, we want to check our solutions to make sure that they will work in our original equation. We've changed it by doing the rules for logarithms. The positive value, 2 root 6, the square root of 6 is a little bit bigger than 2. 2 times something bigger than 2 is going to be something a little bit bigger than 4. So we have something bigger than 4 minus 4, that's okay. And then something bigger than 4 plus 4, that's okay. So the positive solution will work. If we look at the negative solution, again, we'd have a negative 4 point something. That's going to cause us a problem here in this first logarithm. It's also going to cause us a problem over here. Since we can't take the log of a negative, we can't use our negative solution. So the only solution is 2 root 6. Now that we've solved this logarithmic equation algebraically, let's move to our Smartboard interactive whiteboard and solve it using a graphing utility. We're going to solve the equation log base 2 of x minus 4 plus log base 2 of x plus 4 is equal to 3. And when we solve this equation on our graphing utility, we have a special situation to deal with because the calculators generally only deal with base 10 or base e. And here we've got a problem involving base 2. So we're going to need to use our change of base formula as we enter this into our calculator. So we'll go to our graphing calculator. As before, we're going to solve using intersection points. I'm going to enter the left side of our equation in y1 and the right side in y2. When we enter that left side, we need log base 2 of x minus 4 first. We're going to use the natural log, though, in our change of base formula. So we'll do the natural log of x minus 4. And then from the change of base formula, we're going to divide by the natural log of 2. So this expression right now, natural log of x minus 4 divided by the natural log of 2, is an equivalent form for log base 2 of x minus 4. We also have to add in the second part, which is log base 2 of x plus 4. Again, using our change of base formula, we'll use the natural log x plus 4. And again, dividing by the natural log of 2. Now, when dealing with logs, make sure that you're careful about closing your parentheses so that you're not doing any implied operations. So that's our left side of the equation. We'll hit enter. In y2, we're going to enter the right side, which is just the constant 3. We're going to graph that using our standard viewing window. We have the graph of y1 and our graph of y2 that comes through there. We're looking for this intersection point. We'll go to our calc menu. We pick option 5 for intersect. The first curve, we notice there's no y value present here. We're not actually on the graph of y1 right now. So we're going to need to scroll over until we actually see a y value show up. So now that we get a y value there, we know we're on the graph of y1. We'll hit enter. Second curve is y2. We're on that, so we'll just hit enter. And for our guess, we're actually pretty close to our intersection point, but we're going to scroll over just a couple more So we're a little bit closer and hit enter. And we get our intersection point is roughly at looks like about 4.899. So we'll go ahead and drag that over. So using our graphing utility, you can see that the solution set to this equation will be roughly 4.899.